Right, let's look at we can make real big impacts. Wastewater. Now things have changed quite a bit now compared to 5 years and 10 years back. But in general, if I have to say to you, you have a high density commercial area and you now need to start treating wastewater and use it. How many people think it's possible to do that in a high density city environment? That's only 4 people in the entire room. Well, okay, you're one of the 4, Laura. Let me show you something. First of all, let's look at our water cycle. We have our catchment area, which normally the water ends up in a dam somewhere. We abstract from that dam, we put it through a filtration system, we use it, we discharge it through an overloaded municipal wastewater treatment works, and we pollute our water course. Now this is very important. Remember what I said earlier, when you flush it, it's gone, it's out of sight, it's not your problem? Look what's happening here. It's coming back to be your problem because you're feeding it into water course that feed your drinking water. I do apologize for the sensitive ears, but you're literally pouring in your own drinking water. When you discharge your wastewater to a non-functional or overloaded municipal wastewater treatment work, you're pouring in your own drinking water. There's no nice way to say it. Okay, now, but in my town it's different because in my town this wastewater system discharged below the dam wall. Oh, beautiful, you just feed it to your neighbor. Come on, where's Ubuntu here? That's what we end up doing. At a previous meeting, I said, okay, everybody by a show of hands who believes eating healthy is good. And just about everybody put up their hands, and the next thing I asked is, who likes some nice grapes every now and again? And everybody put up their hands again. I said, now you think if you flush a problem in Gauteng, it's going to go down the Vaal River, it's not your problem? Guess what? Your grapes come from Uppington. The farmers in Uppington has a problem with E. coli in their water in the river because that river is coming from Gauteng. So you export your sewage problem to Uppington and you import it back in the form of grapes. That's how the water cycle works, whether we like it or not. But there's another little problem here. The other problem is if you look at the carbon footprint. Again, not many people think that water has a carbon footprint, okay? It's a natural thing. How can that have a carbon footprint? Would you agree? Well, the problem is, if you're in Pretoria and you get water from the Vaal Dam, what's the figure? About 60% from Victoria's water coming from the Vaal, I think. Well, if you look there, that's 124 kilometers line of sight. So you're looking at about 150, 200 kilometers of pipeline that you need to pump that water. But your problem is from here to there is a 300-meter rise. You need 30 bars of pressure to lift the water to Joburg before you can flow it down to Pretoria. 30 bars of pressure, to give you an idea, your irrigation system at home runs on 3 bars. Your average geyser runs at 4 bars. We're talking 30 bars here to lift that water to Joburg before you can get it to Pretoria. What is your carbon footprint on that pipeline? What is your carbon footprint on those pumps? What's your carbon footprint on the electricity that you use for that? Now we're not even talking purification and all the other stuff that goes with it. So your cost and your carbon footprint becomes huge in cases like this. So what we now do is we start thinking a little bit different. When we do on-site reuse, so whatever wastewater we have here, we treat on-site, we take it back. We now start talking about increased water resilience. And remember, every time you flush a toilet and you treat it, you have water to flush the toilet again, no matter whether the municipal water is on or off. So we're also talking continuation of operation, because people can stay on site, at least they can use the ablutions. Yes, you may have to buy from your local grocery store water for making coffee, but at least you have water for ablutions that you don't have to truck in. But the minute you do this, you reduce your abstraction from your water course. You reduce the pressure on your treatment system. You reduce your discharge, you have fewer overflowing sewer manholes, and you reduce the volume in Olifantsfontein wastewater treatment works. So you get a better quality effluent feeding the Hennops, which eventually feeds Harties again. So you improve your total water cycle. You score big money here. Coming back, I don't have the figures on right now for City of Tshwane, but City of Joburg, commercial again, we're talking 98 Rand a kiloliter to get water from there. For commercial reuse here, you can do it for as little as 8 Rand. A saving of 90 Rand. There's a saving of close to 90%. Which other investment will give you a saving of 90%? Come on, think about it. Financial savings, financial benefit because you have water at least for ablutions or other non-drinking purposes. Your doors can remain open, you don't have to close down like the Supreme Court. And you have a positive effect on the entire water cycle. Again, if you reduce your usage here, you leave more water there, so you build resilience from that point of view for your drinking water. So it's a win, 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 win all the way. In 2020, the University of Stellenbosch, and I'm not going to try to give you all the details, but in 2020, the University of Stellenbosch said, retaining and recycling water to address water scarcity in the city of Cape Town. They looked at all possible water sources taking Cape Town into the future. They excluded desalination because of the cost. And there's this whole document. If anybody wants it, we can email it to you, talking about the benefits and how you can move forward and how recycling will save the day and for Cape Town become a water source for the future. Exactly the same thing applies here. I'm going to show you one technology. There's not enough time to go through different technologies. Yes, it is our technology. I'm a little bit biased here, okay? The fusion system, which is an underground installed wastewater treatment plant, and it will recycle your water on site for you. Comes standard with a panel that has an early warning system, so if anything goes wrong with this system, it will immediately warn you before you have a pollution problem. And these early warning systems, I think, are critical, because something can go wrong, it's man-made, but you need to know when things go wrong. These 7 steps, I'm not going through them in detail. I can tell you that quite a number of wastewater treatment plants in South Africa, I almost want to say 90% of the small plants, stop at stage number 3. These stages are missing. And you can take it with anything, even if you bake something at home, take out half your ingredients of the recipe and see if that recipe is going to work. There's certain things that are needed for a wastewater treatment plant to work. So before you look at the price, because that's what most people do, before you look at the price, look at what you get for the price. Because I've seen that so often. People buying cheap and then having to remove it again later. I'm not going to spend time on the technical side of it. Just keep in mind, without disinfection, there are at least 6 steps of treatment that need to happen to get to the water quality that by law you need to get to if you want to use a discharge as water. Okay? But at the same time, again, for pollution, otherwise you end up weighing again in your drinking water. Case studies. Where do you think is the highest risk installation you can have in terms of if your system fails, you will have big problems? Where do you think is the highest risk installation? Let me see if I can get 2 or 3 people to answer that question for me. No, you're not allowed to. You know the answer. Come on. You know the answer to Nora, you're not allowed to answer. And so does Andries and Arne. I'm listening, sir. Close to any natural water system, yes. But if you step it up a bit more, where's the highest risk? How about the Department of Environmental Affairs? This is the Department of Environmental Affairs in the city of Cape Town. You can see it's dense city. There's no space. You see in the middle of the building there's a tree growing out there. If you take a closer look, that's the same tree. If you look outside, there's no space. Okay, you can't do anything here with water. You can't harvest rainwater, there's no space. You can't recycle, there's no space, okay? Everybody agree? Look at what we've done. In that quad, surrounded by high-rise buildings, 2 meters away from Environmental Affairs boardroom, we recycle their wastewater and we flush their toilets for the last 6 years. I see Nora nodding here. Nora's been there. She did an audit on this thing. The user experience, Nora, good or bad? Very good. This is what we're getting out of the system. And we've cut the water demand by 50%. Remember I said for domestic toilet flush is about 30%. Here we're talking about the commercial building where toilet flush can be up to 90%. In this case it's 50% because they have showers and stuff as well. So you've just cut your water bill by half. But you have water resilience, you always have toilet flush water. For 6 years going now, I think the case study speaks for itself. You can do it in the city, you can make a positive difference. And that's why today's theme is talking solutions. Because we hear so much about the problems out in the media already. Let's talk solutions. This is on a small building. You can see how nicely it blends in with the gardens. There's your treated effluent again. Your air pump. Now the air pump, going back a little bit, there's your air pumps there that's applying. We had to put in 4 small plants because we physically had to carry them through the building. We couldn't put one big plant in because it just wouldn't fit. But that again is the beauty of having a Lego set. You can pick what's needed. So hiding that air pump there in the garden, we use the false rock. In the walkway, in the paving, if you want to drive over it, you've got to do a proper slab. I know Andries has done one where people drive over it in the driveway feeding to an hotel. Unfortunately, Andries, I don't have that photo in the slideshow, but that is also possible. Hospitality industry feeds into the fusion, they use the water for irrigation purposes. There is farms, houses at the farms. Kiddo School, Bloemfontein. Again, you can see the treated effluent, they're using that for the sports field irrigation. But the beauty, now we start talking modular systems because this was designed for a school having a maximum of 600 learners. So then the school grew, they're just over 800 learners now, so the wastewater treatment plant is too small. Oh, big problem. Nope. We just dropped in number 3. And now they can go up to 900 learners. When they go above 900, we drop in number 4. And so we can expand as the demand of the site expands. Isn't that beautiful? These are mostly on grease installations. So staan net voor op en almal kan sien wie is jy. Jou arme jy kan maar saam opstaan, julle is saam aan die besigheid. They've been doing this in Gauteng since 2012. So these are all installations that Greece have done above ground. Some of them are in Mpumalanga, some are here, not very far from here in fact. Then if we look at bigger developments, this one is in Katima Molilo, Namibia. Each color is a different phase. So there is phase 1 coming in. They've got 2 phases up and running now. These ones are now up and running, and these phases will still come in. So even within the development, rather than having a central sewer system at a huge cost and pumping stations, because it's relatively flat there, they decentralize within the development, and each phase will get their own set of treatment plants, and they will reuse the water in that phase for irrigation purposes. What a beauty. You literally do clusters as you move along. There you can see the final grade of the system. This one we did phase 1 in November last year. You can see many more phases to come. Again, this is in KZN's typically hilly areas. The EIA experts will now tell you what a nightmare that become in terms of, well, some will make a lot of money, so for them it's not a nightmare, but every time you have a waterway crossing or a catchment crossing, the EIAs you need to go through, and the pumping stations to pump it up 50 meters or 100 meters. So in this case, it will be fully decentralized. This is the shopping center that we've done here, shopping center, filling station and church. And the rest of this development will come as they build. The next phase is in a few months from now. So there you can see what it looks like. These 7 plants standing here will service the shopping center, the filling station, and the church. In the case of a domestic setup, this will serve 140 houses. It uses 2.5 kilowatts per hour. That's nothing. For 140 houses, 2.5 kilowatts per hour, that's just for the treatment, it excludes pumping back and so forth. It's out of sight, fits in very nicely with your landscape. There are a few more projects like that coming up, and in future we will have some more to show on that. There you can see the 7 tanks during the installation period. This is a filling station, again the treated effluent. A mining village, again the treated effluent, which they wanted to use for growing veggies on site there. A campsite. Okay, here you don't put your drinking water, you sleep next to your pool. But imagine from a noise point of view, you're out in nature, it's all quiet. These are individual campsites, so you don't have a neighbor. And you've got your air pump running there, you don't hear it at night. Kango caves making use of this technology, where they pump their wastewater up to that point. It gravity feeds to a lifting station here. They pump it up, treat it, pump it higher up on the mountain, and bring it back for toilet flushing and for irrigation. Frologate Nature Reserve, the Whip Nature Reserve, where you go on the whale trail, you will have your fusions there treating your wastewater. There are more nature reserves. There's a botanical garden, a few others as well. We cannot do all of them. So the case studies is just to show you it is possible in just about any location. Different technologies are suitable better for certain locations. But you can do it anyway, and you can recycle 100% of your water for non-drinking. If you want to take it to drinking purposes, then you go through a reverse osmosis system. You will have, depending on the system that you use, anywhere between 25 and 45% waste. So there you do lose water. But it also becomes more expensive. We are busy with a case now where there is no drinking water. There is no municipal supply. The borehoules can only deliver 8% of the total volume needed. Rainwater harvesting is difficult. It's going to be done, but for 3 months of the year there is no rain. So the only option left is that we take treated effluent back to drinking water standards, and then blend it in with the rainwater and the boreholes to be the total answer. So it's doable, but it is your more expensive solution. Your cheap solution is to use that for non-drinking purposes and save your expensive water for drinking, for showering, for human contact. Okay. Taking lead from the Cape. Now remember, you've already seen, I've got to be very careful, I know I'm in a global country now, so you've already seen University of Stellenbosch, the study that they've done, and I just want to mention something on that. That papers talk about industrial reuse. After the paper was published, I met with a professor and he said to me, Gerhard, but what you're doing is changing our model completely because you can now do domestic water as well. Reuse become a much bigger factor. Obviously, they're not going to rewrite the paper. City of Cape Town already in 2018 bylaws said renovations and new developments must make use of water conservation and demand management systems or alternative water systems for non-drinking purposes. It's already by law in Cape Town. And I stand to be corrected, but I believe that Ekurhuleni is also coming to a point where they said new developments must do their own wastewater treatment because they can't do it anymore. So these things are changing. Municipalities used to resist this. They don't really have an option but now to adopt this. Green Cape has done a study also in 2020 promoting on-site treatment and reuse. I may be in trouble for what I'm going to say now, but I'm not known to be scared of trouble. Green Cape, their purpose is to promote green technology. Started up and funded by the Western Cape government and City of Cape Town. Now these are private funders as well. I couldn't quite get Green Cape to buy into this thing. They did a lot of other green stuff, but this wastewater recycling thing, they didn't like that idea. Until I went to show them the case study at Department of Environmental Affairs. 3 months later, they issued this paper, because then they saw in proof what is possible. Another study by them was the Kangaroo Caves. You can read up on the website. They actually give you the numbers. And this is the first property where we did on-site wastewater treatment, August of 2010. The beauty is they're moving that house now. They've broken it down last year, they're moving it. They're taking out the infusion, they're moving it with. So there's some green material. Also going to the Solar Impulse Foundation. There's only 2 companies in Africa that's listed with the Solar Impulse. This is one of them. So I think that is, and to list there's a set of criteria, and one of them is you must already be in commercial operation. It's not a trial or a design or a test phase, it must already be commercially accepted. Then when we look at on-site wastewater, I'm not going to spend time on that, but we speak to 13 of the 17 SDGs. Not all 13 necessarily on the same site, but we speak to 13 of the 17 SDGs. Now, to all the corporates sitting here, and all the consultants to corporates, if you want to increase your SDG score, have a look at this. This is a way to do it. Now, you can take it one step further. If you do need to spend, if you're corporate, you need to spend your corporate responsibilities. You need to spend money in the communities. When you spend money in a community, you start talking about no poverty, because people can use the water to grow food. You talk about zero hunger. You talk about gender equality. You talk about health. How do you talk about health when you're talking wastewater? It's very simple. Kids don't play in sewage contaminated soil anymore because you're giving proper sanitation. So when you fund something like this for a community, you score SGDs, but you also have your points for your community responsibility. So it's a double win yet again. And lastly, this is specific to our company. If you look at partnerships, the way we do it is we partner with local installers and local maintenance people. So we create local wealth, build a local economy. And that's where the partnerships come in. For those of you who say, yes, I'd like to do this, but it's too expensive, I don't have 100 or 200 or 5 million, whatever the case may be, to spend on this intervention, it can be financed. We're working with Capital Box there. So you can finance it, and your saving in buying water can carry your installment. So you're cash flow neutral until your investment is paid off, and then you're cash flow positive. So you can get involved in this intervention without having to fork out the big money that you don't have. There is also a possibility of rentals that's a bit more strict, but there is also a possibility we have companies that don't want to buy the equipment, they don't want it on their books, but they will rather have the operational expense of a rental. It is also possible through a financing model. So ladies and gentlemen, with that, I want to say on-site recycling will increase your water resilience. It will reduce your overhead expenses in not buying water, or buying less water at least. It will reduce your carbon footprint, increase your sustainable development rating. It will increase your ESG score because you E, environmental, you need to drop your water consumption by 20%. You can do it with this. So you can score on your ESG. And you save our water courses, which Darren will love when you go off grid. Thank you very much.